All right, this question asks us about figuring out the different temperature of vaporization under reduced pressure. So what it gives us is it gives us the delta H of vaporization. And it gives us temperature and pressure under which the substance vaporizes, or the temperature and pressure that it vaporizes at. Now we can figure out a different temperature under different conditions, under different pressures. And if we use the Clausius-Clapeyron equation, so the natural log of the pressure 2 over pressure 1 equals negative delta H of vaporization divided by R times the quantity 1 over T2 minus 1 over T1. Now notice T2 and P2 have to go in these positions, T1 and P1 have to go in these positions. Ultimately, they need to match, but let's go ahead and get in the habit of labeling the way that you want. Just be consistent in your labeling. So let's put things together. So the natural log of P2 over P1 would be 1 atmosphere in the denominator, and now what goes in the numerator? The problem says the pressure is reduced by 75%. So what is 75% less than 1? Well, that's 0.25. So 0.25 atm is pressure 2. And so let's plug in the rest of the information. The delta H of vaporization is 40.7 kilojoules per mole. But take a look at R. R is going to be 8.314 joules per mole Kelvin. So we need to make sure the energy units match. So instead of kilojoules, we need to go to joules. So 40,700 joules per mole. Now, 8.314 joules per mole Kelvin. I'll go ahead and change that later. 1 over T2 minus 1 over T1. And now look at back up at the top. T1 is given to you in Celsius. But again, the gas constant is 8.314 joules per mole times Kelvin. I'm going to add that back in here in just a second. So the temperature needs to be in Kelvin, 373 Kelvin. Okay, now that I got it all together, I can solve for T2. So the natural log of that ratio, 0.25, is negative 1.38629. 40,700 divided by 8.314 is 4,895.36. There's my Kelvin. I'm going to go ahead and run that through the parentheses. So that's over T2, and then I'm going to go ahead and divide 4895.36 by 373. I get plus, because negative times a negative is a positive, 13.12428. So subtracting 13.12428 from both sides, I get negative 14.5106 on the left. And I get this quantity remaining on the right. Let's move that up a little bit. And so now solving for T2, I get T2 equals, just a quick note, negative times a negative, that's going to become positive. So T2 equals 373 Kelvin. And if I convert that to Celsius, I get 64.4 degrees C. And that's the final answer.